Welcome to EDU World Space.
All right, so we have here three planes of charges arranged as shown in the figure. There are points A, B, C, and D at which we need to find out the electric field. Now the point and the plates are, the first plate is negatively charged, second plate is positively charged, third plate is negatively charged. So accordingly, the point at point A, the electric field due to the first plate E1 goes towards negative, because electric field always has the direction from positive to negative. So always goes towards negative and away from the positive. So since this is negative, so it goes towards the negative. Similarly, E2 is positive, so it goes away, it comes away from the positive. E3 is negative, so it goes again towards the 3, right? Similarly, we have E1, E2, E3 for all these points B, C, and D. Now, to calculate, we use for electric field due to plate, first, for the first one, EA is equal to, now I will consider the right hand to be positive, okay? So E1 minus E2 and plus E3. You should note that, well, I will tell you in a minute, and where electric field due to a plane charge is given by sigma upon 2 times epsilon naught, where sigma is the surface charge density and epsilon naught is the permittivity of the vacuum. Now, while using this formula, we don't need to care about the sign of sigma, because that is already been taken care of by the direction of electric field. Like for example, I have introduced minus here, right? So that corresponds to, the difference in charges, right? So we don't need to bother about the signs of sigma. Just we can plug in the magnitudes here. So to calculate the first one, plug this as sigma 1, just the magnitude, okay? Sigma 1 upon twice epsilon naught minus, we don't need uh, magnitude here because sigma 2 is already positive. So sigma 2 upon twice epsilon naught plus, now we need magnitude here, sigma 3 upon twice epsilon naught. Now if you plug these values in here, this gives me 3.4 into 10 to the power 4 Newton per coulomb. Since this comes out to be positive, so it means it is along right. The direction of the net electric field is towards the right. Alright, so electric field, similarly electric field at point B is equal to minus E1 plus E2 plus E3. Alright, now this is equal to, similarly E1 is equal to minus of sigma 1 upon twice epsilon naught. For E2, it is simply sigma 2 upon 2 epsilon naught, and for E3, that is plus sigma 3 upon 2 epsilon naught. Alright, so this gives me a minus of 2.3 into 10 to the power 4 Newton per coulomb. So this means that the electric field is towards left, right? And the magnitude is 2 into 2.3 into 10 to the power 4. Similarly, for EC, electric field at point C, it can be written as minus of E1 uh, plus E2. I missed a sign here. For E2, in place of EV, this is E1 minus E2. But don't worry, the calculation is all right. Okay, so just it is a change of sign here. I have calculated correctly. Okay, so let's continue with EC now. So minus E1 plus E2 plus E3. So We can even write just sigma 1 because minus of modulus is again minus. So just let me write sigma 1 here. Sigma 1 by twice epsilon naught. Now E2 is what? Plus sigma 2 upon twice epsilon naught. Now E3 is negative. We need plus, so modulus sigma 3 upon twice epsilon naught. Now this turns out to be 5.6 into 10 to the power 3 Newton per coulomb. Since this is positive, again to the right. Now similarly, electric field at point D is equal to minus E1 plus E2 minus E3. So minus E1 is simply sigma 1 upon 2 epsilon naught plus sigma 2 upon 2 epsilon naught. Now minus E3 means that we can just add without the modulus, right? So this finally gives me 3.4 into 10 to the power 3 Newton per coulomb, negative of this. So it means that the electric field is towards the left. Alright, so this ends the solution to this problem. Thank you for